Hello and welcome to the tutorial series of creating customized app GUIs for SystemVue using C#. This is the final and concluding video of this tutorial series. So in part 1 and part 2 videos, we learned basic of SystemVue and C#, controlling SystemVue parameters from C# using the console application. In this video, we will extend our learning to create a custom GUI and set all the parameters which we need through the GUI and not always open the code to set those. Now, in order to do custom GUI, we can just simply add a new project to our existing solution. And this time we will add a Windows Form application, which will allow us to do a customized GUI. We'll give it some name. Let's say, for example, in this case, radar_GUI. Click OK. And now we will have a new Windows Form application loaded into our project. Now this application, we can set it up as a startup project, so that's the top level in our solution workspace. And it comes up with a blank form. As you can see, you can resize it by moving, using the mouse, or you can set the size of the window, whatever you need from the properties window dialog, right? So in this case, we'll go ahead and set it up to 640 by 480, which is decent enough, size for the thing which we are trying to do. Right, so under the form, the first thing we would like to do is give it our own title. So there are a couple of names. One is the design name, another is the text. So we will end up using text. So let's call this as a radar signal generator. Which kind of tells what do we expect from this window. And now as soon as we do that, we have a title bar called radar signal generator. Now if you remember from part 1 and part 2 videos, we are trying to set up a flexible modulation scheme for radar. So all the available things will be under toolbox. If the toolbox is not visible, we can go to view menu and enable all the kind of windows or toolbars which we want to see in our interface, right? So usually toolbox should be visible, but in case it's not visible, we can make it enabled. Now most of the time, whatever we need, we can find under common controls. However, there are other categories in case you can't find whatever you need. Yeah. To start with, we will start using the radio button. Essentially, we will place 3 radio buttons, allowing us to set the modulation type. Now the good practice is you set and configure one button, and you can just simply copy and paste using Control C and Control V. This also helps in creating consistency between the options in your user interface. So we configured the one radio button, and we'll just simply copy paste this radio button to have 3 radio buttons. And now we can go ahead and update our text to Barker. And also for the third button, we'll go ahead and change it to FSK. So these are the buttons which we will use later in this tutorial video to select what kind of modulation scheme we need. Also, we can go ahead and use a label. Label allows us to give or write any text in our GUI. And we can again set the font, color, whether you want it italic, bold, all those kind of things using very, very simple, toolkit here, right? Now, we also will put a label, and again, we will type something like radar signal generator, so that it gives a feel of what is intended to be done using this window. Again, all these properties like background color, the panel type, all those things we can very easily configure using the properties option. You can go ahead and select the color of your choice, whatever suits you or your application the way it is. We can also play around using the color, and this color can also be dynamically set, by the way, from the code which we are designing. You just need to remember the coding of that color. So I'll go ahead and fix silver for our tutorials. And now we need to place 2 buttons which are the most basic ones. So we can go ahead and pick the button from the toolbox menu. So we will use one button to execute our program and another button to close the program. So we'll go ahead and size the button according to what we need, and go ahead and give it some text to this button so that we can identify this button while we are running our program. So We'll go ahead and give it a name, generate radar signal, which essentially means it is the one which will help us executing the code. And again, we go ahead and set up the text properties or the font properties. Now, once our button is set, we can simply copy paste the button using Control C, Control V, and we will go ahead and just change the name. Now, one nice thing about Visual Studio, you get all the alignment markers and alignment lines, so it helps you kind of creating a very neat looking GUI with great ease. Yeah. Now remember, some of these buttons we will use later in our code to access the data or to run some events. So it's always a good practice to give these buttons some names which you can remember easily. And also you can prefix or suffix a few things as you go along. So in my case, I will just prefix everything with BTN name. So which kind of signifies it's a button which I'm referring to. So we'll call it BTN LFM, BTN Barker, BTN FSK. Similar to these radio buttons, we will also use the identifiable name to our execute and exit button. So here for execute or generate radar signal, I'm going to call it BTN execute, and for exit, let's call it BTN exit and click OK. Now remember that C# is case sensitive, so whatever names you are giving, you need to remember the syntax. So you just go ahead and define a rule. Now at this moment, our App GUI is in decent shape, and now we need to create an event on what happens. So if you just simply double click on an object, it will create that event in our background code. So here, as you can see, I have a BTN execute click. And this is the field where we would type whatever we need to happen. Yeah. So before we do that, let's create an event for exit as well. So we go back to design, double click, and now we have the method created for exit. So while we do that, I need to remember a couple of things. One, the syntax, it is quite case sensitive, right? So make sure you use the right name inside your code to whatever you are assigning in the design GUI. So now we'll try to call SystemVue class, and as you can see, we haven't yet added the reference to that. So hopefully you remember from the last video, you got to add the reference of SystemVue net file, and that's where you will get access to all the SystemVue methods and classes. So we'll go ahead and initialize it like we did it in the earlier videos. Just create a new instance of SystemVue so that we can use it in our code. Or if you already have that code, you can just simply copy paste these things from the code itself. So you don't need to really write it. But I'm writing it here just to make sure you still remember what we did. And also not to forget, always put a semicolon at the end of your command. Right. So now SystemVue instance is located. Let's go back and see here. So that's the code. We can just go ahead and simply copy paste from there. So let's copy paste our open workspace command. Just say Control C, come back to our form.cs code, and we'll just paste it here. So now it's the same workspace which I will be working whatever we were using earlier. And now let's make SystemVue visible. Again, we can try copy pasting, but something worthwhile to link to the earlier videos. So we'll just make visibility to true. And now we can go ahead, instead of writing all those commands which we have already tested in our earlier tutorial video, we will go ahead and bring it from the program.cs. So we'll just copy paste this entire stuff there except the console line. Now because we are working on GUI, we really don't need the console statement. So I'll go ahead and paste it here. Now all the parameters are already set. So before we proceed, we also need to create an event for exit. And two things we want to happen once we click exit button. One, SystemVue gets closed. For that is a simple method called exit. And also we want to close the form or the GUI. So we'll just use form.activeform.close method to close the GUI app window. All right. Now with these two things done, we are pretty much in good shape to go ahead and just do an initial trial to make sure everything is working okay. So we can right click and build a solution because this is first time we are doing it. So Let's see if everything succeeds without any errors. So indeed, so you have one build which is succeeded and two are already up to date, and those are SystemVue Net and the demo SystemVue. Yeah. So again, we can run it like what we did earlier. We just click on the start button and wait for the GUI window to come up. Remember, it will launch the system view in the background, so it will take a bit of time. And don't get confused by looking at this window. That's not your GUI, right? So this you can try clicking. Now here is our GUI, which you can move around in the screen and make the selections. However, these radio buttons right now have no action defined. So let's click on the generate radar signal because that is what has been implemented. And now you can see using that button, the system view action is getting performed. So it's a very neat way of doing that. So let's exit from here. Now we have created a method for generate radar signal. Now let's add the control of our modulation type selection. Yeah, and the simple thing to be done in order to access those is put some if conditions. Yeah, so we will say which button is checked. So if we type if btn lfm, remember, so that's why you should give it an identifiable name. Btn lfm dot checked, and if it returns a true condition, we would like to do this operation. We just simply nested the statements into the curly braces. We can also set another condition for Barker. So we say but btn barker dot checked it dot true, and now we can type what we want to happen if somebody checks Barker. So we'll declare the variable mod type and we set the value to 1. Hopefully you remember the mod type 1 is for Barker, and we can copy paste the run analysis command from our earlier code because ultimately we would like to run that. We create another if for our third button, which is nothing but btn fsk, and we would check whether that button is selected during execution. And again, it will have the same operation which will happen in Barker, except the modulation type will now be 2. Right? So we'll copy paste and modify it to 2. Now see here that we have defined the modulation type, but we haven't set the modulation type in SystemVue. So we'll go ahead and copy modulation type set parameter statement, and we put it before run script. Hopefully you remember from video 2, we need to set parameter first before we run the simulation. Now let's give it a try and see if our code is working okay. So we'll just click on start button and wait for a while to for SystemVue to come in. Now again, as I said in the last video, it's always a good practice to keep testing your code in parts, especially if you're new to this programming. So now you can see we have selected LFM, and if we click generate radar signal, obviously the LFM simulation runs and the code is activated. Now let's try selecting Barker and see what happens. So if we select Barker and we click on generate radar signal, we get an error. It says workspace is already loaded. So you're trying to load something which is already loaded. So we know the problem. So we'll just go ahead and make sure the Barker gets enabled. We are running the simulation, and same thing will happen in FSK. Yeah. So main of the problem is that we are trying to open the workspace in the execute button scope, right? So if you go and check our code, so every time we click generate radar signal, it is trying to open a workspace, which is a problem. So there are two ways to fix it. We can always put a check statement, or we can just double click on the form window to create an event. And instead of opening the workspace when execute button is pressed, we can just simply cut and paste it so that SystemVue opens the workspace as soon as the GUI window is up. But it will keep it in hidden mode by default. And as you can see, we have SystemVue Visible statement written in execute command. So whenever we click the button generate radar signal, only then SystemVue will become visible. So that's kind of nice way to do that. Yeah, because you don't want to throw up SystemVue open as soon as you have the GUI. So now let's try to test it. We click LFM, of course it is working earlier. So let's test Barker and make sure it happens properly. We select Barker and say generate, and of course now they see there's no problem in our code. We select FSK, we run simulation, and now we have FSK spectrum. So now the basic things are working properly. So we have two main buttons working properly. We can make the modulation selection. Next step is to make sure we have a configurable design so that we don't hard code these parameters of modulation. So we need to create some options in our GUI so that we can pass in the parameters. Now this can be very simply done using Textbox. So I'll go ahead and put some text box, and we scale the size according to whatever we think is appropriate. And we just simply use Control C and Control V to have as many text boxes as you want in the GUI. So here we need 4 of them, one for bandwidth, one for pulse width, one for PRI, and others for carrier frequency. So we'll just simply put these 4. And again, we will name them because ultimately we will need these information typed in these boxes in our code. So we'll go ahead and name them as TXT, BW, PRI, PW, and so on. Again, I'm prefixing here TXT just to identify that it is a text box. However, it's not mandatory. It's just my way of working to remember what I'm typing, which form I'm accepting. Yeah. So we'll assign those 4 names to these 4 blocks, and in order to let user identify, we'll put some labels, yeah, so that you know what parameter you need to type in this field, yeah, without which it will be kind of difficult. So we'll go ahead and change the text to PW for the first box, and then we copy paste, and then we make another block. We place 4 labels for each of the blocks, yeah. So we go ahead and define PRI, so bandwidth, and then F carrier. So these are the 4 things we will need. And again, don't mismatch the labels and the type of text box information you are looking at. We'll copy paste those 4 things on the right hand side of these boxes, and that's where we will specify the units so that user can enter the right kind of data. So for PW and PRI, we'll keep it second, and bandwidth and F carrier will keep it as hertz. So now everything is okay. The GUI looks in decent shape. We just need to set up our code to accept these values, whatever user types there. So the first thing we will do is remove the value declaration or value assignment from our variable. So we'll remove all the values because now we will read in the values which is written in the GUI text box. Yeah. So we'll go ahead and remove all of them and just have a variable declaration. Now this baseband sample rate or bbsr is the equation or which is dependent on the bandwidth. So we'll just take it out from the variable declaration for the moment, and we'll keep it in a separate declaration just to keep things in a more straightforward manner. Yeah. And now we can also define bbsr data type as double and put the semicolon then. Now in between we need to read in the values which is typed in the GUI. So we just say LFM underscore bandwidth, for example, and remember txtpw is the name of that block, but here it is giving you an error saying that you cannot implicitly convert it. So we need some kind of typecasting. The easiest one to use is a convert class, and then you have a method to double, to integer, whatever format you need. So you go ahead and type convert.toDouble and the text box name and .text. So that gives you the text which you have written in that box. Similarly, we'll go ahead and set it up for other parameters. Oops, there was error. So instead of PW, it should be bandwidth, BW. So I'll make that correction. And you can either copy paste and just modify the text, or we can go ahead. It doesn't take too much of time to create. Now this is kind of pretty important because you need to remember you're typing in a text box, and text box inherent property is a string. We want to use that number, that the text which you write as a number in our code. So we do this typecasting. Yeah. There are other ways of typecasting as well. We can go ahead and parse it like a double or something, but for a new user, this one is probably the easiest method which I found. So I'll go ahead and do our final variable assignment, which is F carrier. I'll go ahead and convert as a double data type to this. Now with this, our code is ready to be tested again, and we'll see whether the values which we are typing in our code is getting read by our code, and then we go ahead and set this up into SystemVue. So let's click on the start button again and start testing our code. Wait for a few seconds for SystemVue to come up. All right, so now we have a window, and now we can type in the value. So let's say we go ahead with 10e minus 6 seconds, which is 10 microsecond. We'll go ahead and specify PRI to 100 microsecond, bandwidth as 10e6, which is 10 megahertz, and F carrier to be something very different, 10 gigahertz or 10e9. So let's go ahead and run simulation. And now what we can notice that of course we have a 10 gigahertz carrier, and then if we zoom in near to LFM block, and we can see all the properties are as per our GUI which we just set up. All right, so this seems working okay. So let's try changing the bandwidth and see whether everything is working fine. We click on generate radar signal again, and oops, we have a problem. So by changing bandwidth parameter, if we can see the zoomed in, the sample rate doesn't change. Also the sample rate block doesn't have this updated. Now where is the problem? So let's try fixing it. So we exit the button. And now notice that we calculate baseband SR variable in our code. Somehow we are not updating SystemVue with that. So we're just calculating and keeping it in our C#. So let's go ahead and correct that mistake, and we will insert a new set parameter statement. And we will go ahead and update the bbsr variable which we calculate, so that dynamically whenever somebody changes the bandwidth, the sample rate changes. Again, you can come up with your own logic. You can also give user the type of sample rate he wants to set and things like that. Yeah. So here I just took up fixed 5 times of the bandwidth. Yeah. Okay, so we'll go ahead and test it again by entering the parameter, and this time we'll enter 100 megahertz as bandwidth, and we'll try to generate a signal. And now indeed, as you can see, the waveform spectrum looks okay. And we zoom in, yeah, the sample rate is 500 megahertz definitely. Yep. So everything is working okay. And now one caution which I want to show, and that's why we are going to run the Barker. And when you run Barker code with such high oversampling or FSK, right, you will see kind of weird spectrum because it's highly oversampled. So you really need to zoom in to see the actual spectrum. So later you can go ahead and add more options for your Barker code, for your FSK code, and so on. So hope you enjoyed watching this tutorial series. For more information, you just subscribe to my YouTube channel or to the blog page and stay updated. Thanks for watching.